Problem number 13. Calculate the lattice energy of sodium bromide from the following data. Sodium solid gives sodium gas. This is atomization or vaporization, and the enthalpy change, the heat change is equal to 109 kilojoule. Next, sodium gas to Na plus sodium ion giving 1 electron. So del H value 490 kilojoule. This is the ionization process. Now bromine dissociates into two bromine atoms. So bond dissociation energy is involved. So here the bond dissociation energy is given as 192 kilojoule. Next, this is called the electronation process. So bromine now becomes bromide ion, and here the electron affinity is associated, and here minus 335 kilojoule. Del H is equal to minus 335 kilojoule. And another equation, the sodium solid is the overall sodium solid plus half Br2 gives NaBr solid. So this is the overall reaction. For this, del H value is minus 376 kilojoule. And here one very important thing is the lattice energy. So what is lattice energy? So lattice energy is the energy. So in two ways we can define. Lattice energy is defined as the energy required to dissociate an ionic compound into respective ions in the gaseous state. That is 1 mole of an ionic compound we have to take. And here we have to supply energy. So lattice, now it is indicated as positive. Now in another way we can say, so lattice energy, that is the enthalpy of formation, is the heat liberated when 1 mole of ionic compound is formed from its ions, that is cation and anion taken from the infinity. For the formation of 1 mole of an ionic compound from the respective ions, that is positive and negative ion, how much heat is liberated, that is another way of stating. And in this case, yes, minus, but always lattice energy is indicated as a positive quantity. So the problem is solved by writing the equation for the lattice energy, that is step. And this problem is based upon Born-Haber cycle. The Born-Haber cycle is used to calculate lattice energy of ionic crystals, because the determination of lattice energy is a difficult process, and a direct method is not feasible. Therefore, we have to go by an indirect manner. So by constructing a Born-Haber cycle, that cycle is also constructed on the basis of the heat law, that is Hess's law of heat summation. The heat reaction, that all heats involved in a chemical reaction can be added up to get the overall the heat of the reaction. The total enthalpy change of a chemical reaction is always a constant, whether the reaction takes place in single step or many step. So the problem can be solved by writing the individual thermochemical equations and all the steps, and sometimes addition required, sometimes subtraction required, depending upon the situation. So it is solved like this. So lattice energy, for lattice energy, the equation is Na plus and plus Br minus, that is also in the gaseous phase. Now it gives NaBr solid, and here del H value is question mark. So as per the law of heat summation, Hess's law of heat summation, so this del H, so this is 1. Suppose if it takes a del H1 and this del H2 and del H3, here we must be very careful, because so we need only one bromine, and here it is bond dissociation energy is given. Therefore, here this value must be divided by 2. So this del H value must be divided by 2. So that gives 96. So 96 kilojoule alone taken, that is as del H3. So del H1, del H2, del H3, and now this del H4. Here the energy is released, del H4, and del H5. This can be taken as del H5, and if we add del H1, del H2, del H3, del H4, and del H5, we must get this. So minus 376 must be equal to the sum of all these heat reaction values. Only the del H5, that is lattice energy alone is missing. So that can be calculated by, so you have to add 1, 2, 3, 4 and 5 is of course to be calculated. So 4 heat values we have to add and that should be subtracted from here and you get, so the del H1 plus del H2 plus del H3 and here is minus del H4 and finally del H5. So this alone, so all the values are known and this is also given in the problem, and if you take and on solving you get the value. So del H value comes first minus, that is 736 kilojoule comes in minus, and lattice energy is always expressed in positive by the symbol, therefore that is U is equal to 736. So the lattice energy is 736 kilojoule. For sodium bromide formation, the lattice energy is plus 736 kilojoule.